Okay, year 10, I'm just going to give you some tips on answering these questions on amount of substance. So for this, this is the equation you need to be using, all right? And if you're not sure about this equation, okay, you need to go back and you need to watch the first video that I did on amount of substance where I explain what this equation means and how you can use it, specifically what a mole means. So if you're looking at this equation thinking what the hell is a mole, you need to go back and you need to watch that video again, all right? So these first few questions are all very straightforward. You're just finding the mass. So you will rearrange the equation to find the mass. The only things you need to be careful of is that oxygen is O2 and calcium chloride is CaCl2 because calcium is in group 2. So it's a 2+ ion, and chlorine's in group 7, so it's a 1- ion. So the formula is CaCl2. All right. These questions are even easier because it's just now moles is just mass divided by relative mass. Things you need to remember are fluorine gas is F2. Beryllium fluoride, well, beryllium is in group 2 and fluorine is in group 7, so you know that you're going to have a Be2+ and an Fe-. So you should be able to work out the formula for beryllium fluoride for that from that. Sodium oxide, sodium is in group 1, so it's Na+. Oxygen is in group 6, so it's O2-. So you can work out the formula from that. And potassium, well, that's just a metal. So the formula for potassium metal is just K. Okay, and then this is where it starts to get tricky. So find the number of lithium atoms in 2 moles of lithium metal. Okay, so here the relationship you need to know is that 1 mole equals 6.02 times 10 to the 23. All right, just like 1 dozen equals 12, 1 mole equals this number. So if I have 2 moles of lithium metal, well, I know that in 1 mole I've got this many. So in 2 moles, how many will I have? Okay, and if you're not sure about that, I go over that in a lot of detail in the first video that I did. So if you want more information on this, you need to go back and watch that first video. That I've put a link to that in the original task. All right. Next, this is a very similar sort of thing. However, you will need to be careful because now I haven't given you the moles, I've given you the mass. So this is now a two-stage question. So in this question, what you need to do is you need to first go from grams to moles. Okay, how do I go from grams to moles? Well, I use the formula up here. And then once I've worked out my moles, I can then go to atoms. How do I go from moles to atoms? I use this formula here. All right, so if you're not sure about that, you just need to rewatch that bit again. And the only thing you need to be careful of here is that here I ask you for the number of oxygen atoms in 2 grams of oxygen gas. Now oxygen gas is O2. All right, so you're going to go from the grams of O2 to the moles of O2. Okay, now if I times my moles of O2 by 6.02 times 10 to the 23, that tells me the number of O2 molecules. But the question's asking you for the number of oxygen atoms, not oxygen molecules. So you need to think, well, if I know how many oxygen molecules I've got, how can I work out how many oxygen atoms I've got? All right, and it should be fairly obvious what to do. If you're not sure, just pause it and rewatch that bit again. Now, down here is where it starts to get a little bit complicated. So, this is how this kind of question works. All right, so what I'm about to say applies to this question and it applies to this question here, okay? So I'll just go through this one and then that should be enough information for you to carry on with the questions. So in this question, you need to write a balanced equation for the combustion of methane. Now, combustion is reaction with oxygen, and it will produce carbon dioxide and water. Okay, now I can balance that equation by putting a 2 there and a 2 there. Now, this equation tells us some very interesting things. All right, it tells us that if I have if I have 1 molecule of methane, I will make 1 molecule of carbon dioxide. If I have, let's say, 10 molecules of methane, I will make 10 molecules of carbon dioxide. But it also tells me something else. It tells me if I have 1 molecule of methane, I will make 2 molecules of water. If I have 10 molecules of methane, I will make 20 molecules of water. Okay, now I can use this for any number. So I could say, well, let's say I've got 1,000,000 molecules of methane. How many molecules of carbon dioxide will I make? I'll make 1,000,000. All right, and I can do this another way. Let's say that I make, let's say I make 1 times 10 to the power of 10 molecules of water. How many molecules of oxygen would I have started with? Well, I would have started with 1 times 10 to the power of 10, because however many water molecules I make, I've used the same number of oxygen molecules. Now I can ask, if I've made 1 times 10 to the 10 water molecules, how many methane molecules did I start with? Well, you can see that for every 2 molecules of water that I make, I started with 1 molecule of methane. So all I need to do to work out how many molecules of methane I started with is just divide this number by 2. So if I do 1 times 10 to the power of 10 divided by 2, I get, let me just have a look, I would get half of that number, which is 5 times 10 to the power of 9. Okay, so again, it's a fairly straightforward process, but if you're not sure, just pause and watch that bit again. Now, this is the interesting part. I could say, if I start with 6.02 times 10 to the 23 molecules of methane, how many molecules of carbon dioxide will I make? Well, I'll make 6.02 times 10 to the 23 molecules. But I've got another name for this. It's 1 mole. So I know that if I have 1 mole of methane, I will make 1 mole of carbon dioxide, and I'll make 2 moles of water. All right, so let's say now that I make 100 moles of carbon dioxide. How many moles of oxygen did I start with? Well, there's twice as many. So I started with 200 moles. All right, so that's how this relationship works using the equation. Now, if I look at the question, all right, here I've got, so I've answered this question already. All right. Now, in the last part, I start to introduce a bit of mass. All right. So don't worry about that too much. All I'm doing is I'm saying, well, let's say I start with 10 grams of methane. How many grams of carbon dioxide do I make? Well, all I need to do is work out how many moles there are in methane, and that will be the same number of moles in carbon dioxide. Okay, so however many moles there are in methane is the same number in carbon dioxide. And then I can convert my moles into grams. All right, so all I do is, stage 1 is I convert grams to moles. I know the number of moles of this, therefore I know the number of moles of this, because it's to do with the number in front. And then over here, I just do the opposite, so I go moles to grams. All right, nice and straightforward. Okay, so hopefully that helps. And I'll see you all in class if you're coming in.